Bit trickier, people. So you might even want to copy this down. Momentum. Is always conserved in two dimensions also, but it's a little bit different. We don't have just one dimension of momentum to look at. We've got two dimensions. And remember, we did this in forces, we did this in kinematics, and we started with vectors. We're still doing it. We just looks. Doesn't sound very good. We just look at each component, x and y. So P before equals P after, just in the x direction. And then we separately do the y direction. So it's a little bit of work. Questions are worth lots of marks. And if you don't show me a lot of decent work, Jakey, then it's hard for me to give you part marks if the answer is not right, okay? So, good habits. Show stuff, good stuff. Even if it's weird and out to left field, it'll still be right. Like, there's lots of ways to do this stuff, right? But at least write it down. Don't just assume I know what you're thinking, Jake. A 900 kilogram car at 30 meters a second east hopefully they're not drunk, rear ends, because then your insurance is null and void, right? A 1300 truck, 1300 kilogram truck at a stoplight. Why even write it? Have we done questions like this before? No, you haven't, and you don't know why yet, but the reason is this is more realistic. After impact, the car is observed to move in a direction of 25 degrees north of east at 5 meters a second. What is the velocity of the truck? Actually, I got to put that here. That's information we need. I said at a stoplight. I just didn't write it, but we need to know it stopped, right? Okay, so. It'd be lovely if I could keep this all on the same screen, but I highly doubt I can do that and write that small. Okay? Momentum before is momentum after. Quickly, there's my car. It's traveling east at 30 meters a second. I'm not even going to write it. Okay? Try to make it as simple as possible. It hits a truck. That's actually, which is 1,300 stopped at rest. That's before. What's happening after? What color was that? Well, the car moves. It's not in one dimension anymore, 2 dimensions. So the car is moving 25 degrees. That's east. I want to go 25 degrees north of east. Okay? So that's the car. There's an X direction, and there's a Y direction. Okay? What happens with the truck? I want to know its velocity. That's the question. Question mark. Any guesses as to what direction it goes after? Could it go like that? This is common sense. Now, it doesn't really matter. You'll get the right answer. The numbers will tell you which way to draw it. But the better you make your picture, the more likely you're not to make a mistake. Common sense. Is this, who plays pool? Like, if you play a lot of pool, you know. If this is one, if that's your cue ball and that's another ball, you know what direction this goes. If the cue ball goes like that, is it going to go like this? Is that possible? No. Any general direction compass-wise someone want to suggest? Exactly 25 degrees south of east, eh? If it was a cue ball or another ball, if they're equal masses, you know, that might be a good guess. These obviously aren't equal masses. But you said south of east. Are you liking this direction? Okay, does that make sense? If this is a ball and it hits that ball and this ball goes that way, you think that ball's probably going to go that way? Okay, good guess, because it does. All right? So like I said, it doesn't really matter, but we want to make it as accurate as possible. That's what I want to know. That's what I want to know, V of the truck. But I can't just get that, because I need to analyze this in the X and the Y directions. Okay? So I need Vx of the truck, and I need Vy of the truck. And once I have those, I'm going to build that to get V, and then I will know, because I need to know not only the magnitude, but I need to know the direction there too. I'll get theta. Okay? So sorry for writing so small, but I don't want to scroll up and down all day. Okay? So that's the strategy. That's what we're doing. P, that's momentum, is conserved in the X direction. So just look at X, what's going on. What do I have for momentum before in the X direction? Is this in the X direction? East is X, isn't it? West and east is X. Yes. So before, well, I have this momentum. What's this momentum? Nothing, right? After, what's the momentum of the car? Here's where components come in. I want Vx. Is that sine or cosine? Cosine, okay? Momentum, so I want 900. I still want momentum, that's mass times this velocity. The component of that is cosine 25, right, of V. Which is Vx. So I'll put it first. But hang on, that's what I'm missing. That's 5. So I know what that is. That's not my variable. Sorry. Okay? I do know the speed of that guy after. So that is the x component of the car, mass times the velocity. The velocity is the component of 5. Goes 25 times 5. Okay? That's momentum. We're all good? Okay. What's the one I don't know? I don't know Vx for the truck. And I'm not going to write T and C for car because it gets really confusing. That's why I changed my colors. Okay, is that a momentum? That's just a speed. What's the mass? Because I got masses here. That's the mass of the truck. So that is conservation of momentum in just the x direction. Do I have one variable? One equation? I can solve for Vx. Okay? And I'll be half done. I need to know Vx. I need to know Vy. So that is 27,000 plus nothing is that. Excuse me. Well, I guess I'll do it on there. Is 4,078. I think we can just round that to the nearest whole. And 1,300 Vx. So minus that from both sides. Don't divide. That's 22,922 divided by 1,300. Okay, I'm going to skip a couple algebra steps here. That is Vx. 17.6. All right. Actually, darn it. For the truck, it's red. Now what? Now I do it with y. P for y. Does this thing have any y components in it? No, it's all x. There's no y. It's not going up or down. And this guy has got no momentum in any direction because the velocity is 0. So before, in the y direction, I got nothing. After, I have y for this guy, and I have y for that guy. For the car, then, I have 5. Y's opposite, so that's sine of 25. But, again, I need momentum here, not just velocity. Yes, there is a way to do it with just velocity, but, you know, I'm not going to teach this twice. All right? What do I got for the truck? Well, I got 1,300, and that's what I need. Need the y component for the truck. So 5 times 900 times sine 25 is 1902, and I'm going to bring that over to this side. So that's negative equals 1,300 Vy divided by 1,300. So I'll divide by negative 1,300, okay? You follow? So Vy, I'm skipping a couple steps algebraically, right? Divide by 1,300, you see this thing's negative, right? See a couple of faces going, ooh. So Vy, well, that's that divided by that, which is that? Well, let's round it, negative 1.5. So what does the negative mean? Yeah. And I didn't write this, but I took east as being positive, right? Which is like our Cartesian coordinate, kind of makes sense. And I didn't write a negative here, did I? That means I took this way for y as positive. So when I got a negative answer, that means down, right? So again, even if I thought the truck went like that, which isn't entirely right, this says that way, and this says that way. And when I add these, that's definitely not this direction, okay? So even if you do a wrong picture, you still need to make sense of this plus and minus thing. That will get you the right answer. Okay, so now I got Vx, I got Vy, I can find V. Let's go over here. I just kind of want to try to keep this on one page. So, part 2, if you will, I got Vx, that's positive 17.6, so that's that way. I got Vy, that's negative 1.5, that's down. Try to make it accurate according to my numbers. That's the resultant. That's the velocity of the truck. And that will be 17.7. Is that the final answer? No. Velocity. I need a direction. Theta is the inverse excuse me, tangent of 1.5 over 17.6, which is 4.9 degrees. Let's just call it 5. Is that the answer? Is that the answer? I'm not done yet. 5 degrees what? North of east, east of south, west of west? Huh? 5 degrees south of east. That's the answer. That's where the truck will go. Practical question, eh? Is that the direction Tanner's truck went? Number 2, 4, 6, and 7. Tricky stuff, guys.